In this video, I'm going to prove the following fact. If we have n is at least 2, then the nth root of n is most definitely an irrational number. Proof. Suppose the nth root of n is not irrational. It's rational. It equals to a over b, where a and b are integers, and the GCD is 1. That is, they're relatively prime, which means a over b is in reduced form. In this equation, raising both sides to the nth power and moving things around, we get n times b to the n is equal to a to the n. Now, you can think of that as n times b to the n minus 1 times b. So that implies that b divides a sub n. A sub n is a multiple of b. But since they're relatively prime, that implies b divides a. Okay, so let's hold on to that. Now, if b is greater than 0, bigger than 1, that implies there exists a prime p. There exists p, a prime, such that p divides b. Every number bigger than, every integer bigger than 1 has a prime divisor. It may be b itself. Okay, now b divides p, p divides b, and b divides a. That implies p divides a. Well, if p divides a and if p divides b and p divides a, we can say, therefore, hence, p, well, we can say that a common divisor of a and b is equal to p. But the greatest common factor, it may equal p, or it may be bigger than p. But p being a prime is at least 1. That contradicts that the GCD of a and b is 1. That was given. We are given that this is in reduced form. Okay. So if b is bigger than 1, when the nth root of n is not rational, hence it's irrational. Now, suppose b is equal to 1. That implies that n is equal to a to the n. Because b to the n, 1 to the n is 1, n times 1 is n. bn is equal to a to the n. But that is less than 2 to the n. N is always less than 2 to the n. Now, that implies that a is less than 2. That implies a is 1 and b is 1. Okay, we're getting there. So the nth root of n is 1. Wonderful. But what can n be? This means that n to the 1 over n is 1. That means n to the 1 over n raised to the n is equal to 1 raised to the n. But that implies, well, I should have it like that, excuse me. But that implies this, which is n to the 1, is equal to 1 to the n. But we said that this was supposed to show that this is true if n is greater than or equal to 2. What I showed was if b is 1, the only way that this is rational is when n is 1. So that's good. That is, I did not show it's rational for n is bigger than or equal to 2. Putting this all together, we get the nth root of n is irrational. Done. If you like seeing proofs like this, subscribe to my channel, hit the like button. Please leave a comment. I love reading them, especially the negative ones. See you guys in the next video. Don't forget to watch and learn.